The search for extraterrestrial life has been a fascinating topic for humanity for centuries. The fundamental question about the existence of life on other planets has driven space exploration and scientific research. Scientists have been using different methods and technologies to search for alien intelligence in the universe. From the analysis of cosmic signals to the exploration of exoplanets, efforts to discover life beyond our planet continue to evolve. As we advance our understanding of the cosmos, we continue to seek answers to one of the most intriguing questions of our existence: are we alone in the universe? But before continuing, you are probably not subscribed to the channel yet. If you want to support our channel, subscribe, leave a like and activate the bell. The theory of the anthropic principle addresses a fundamental question that has fascinated scientists and philosophers alike. How unique are we in the vast universe, and could we be the only intelligent life form, or are we part of a cosmos that hosts other advanced civilizations? This theory postulates that the conditions necessary for the existence of life in the universe are incredibly finely tuned. The anthropic principle states, in the physical and cosmological context, that scientific observations are subject to the limitations due to our existence as observers, attempting to explain, from this concept, the current characteristics of the universe. The term anthropic principle was coined in 1973 by Brandon Carter during a symposium. In his speech, Carter noted that even if our situation is not central, it is inevitably in some respects privileged. With this statement, he intended to draw the attention of scientists to an apparent obvious: the universe and its laws cannot be incompatible with human existence. Initially proposed as a method of reasoning, the anthropic principle has been interpreted in various ways over time. Carter's statement has two formulations. The so-called weak anthropic principle that states that our location in the universe is necessarily privileged to the extent of being compatible with our existence as observers. While the strong anthropic principle states that the universe, and hence the fundamental parameters on which it depends, must be such as to admit the creation of observers within it at some stage. Carter argued that in its original form the principle was only intended to warn astrophysicists and cosmologists against possible errors in the interpretation of astronomical and cosmological data if the biological limitations of the observer were taken into account. He stressed that any scientific theorem, to be considered valid in cosmology, must not include as a condition of validity the impossibility of the existence of life forms in the cosmos. Therefore, the anthropic principle emphasizes that we live in a universe that truly allows the existence of life as we know it. For example, if at the birth of the universe one or more fundamental physical constants had a different value, stars, galaxies and planets would not have formed and life as we know it would not have been possible. Consequently, when formulating scientific theories, we must pay attention to whether they are compatible with our existence. The principle, simple in itself, but not trivial, has been interpreted in various ways, to the point of being used to justify visions of opposite meaning. Several texts maintain that the anthropic principle could explain physical constants such as the fine structure constant, the number of dimensions of the universe and the cosmological constant. In itself, the principle, in its weak formulation, does not explain but rather reduces the field of possible theories and justifies some of them. For example, if we consider factors such as the gravitational constant, the intensity of nuclear forces, or even the precise distance between planets and stars, each appears to be perfectly calibrated to allow life as we know it to emerge and endure. This fine-tuning invites us to reflect on whether our presence is simply a stroke of cosmic luck or whether it could be evidence of a deeper, more deliberate purpose in the very fabric of the universe. Some argue that these almost improbable coincidences suggest premeditated design, perhaps pointing toward some form of cosmic architect. Others firmly believe in pure chance, supporting the idea of a multiverse where countless universes exist with different physical configurations, making it inevitable that at least one has the right conditions to host intelligent life. The Fermi paradox, named after the renowned physicist Enrico Fermi who formulated it, raises a fundamental question that has intrigued astrophysicists and scientists for decades. Why haven't we found evidence of extraterrestrial life despite the high probability of its existence in the vast universe? This fascinating enigma arises from the apparent contradiction between mathematical and statistical estimates suggesting the abundant presence of other advanced civilizations scattered throughout the cosmos and our inability so far to find concrete evidence to support this idea. The simplest solution is that the probability of life spontaneously evolving in the universe to produce an advanced civilization is extremely low. For carbon-based life to evolve on a planet, several simultaneous elements are required. Astronomical factors such as the galactic position, the orbit of the planet and its central star, its ellipticity and orbital inclination, and the presence of natural satellites such as the Moon are determining factors in predisposing a planet to life. Furthermore, although favorable environmental conditions exist, the genetic components of life are chemically complex and lack proven solutions or models for their development. The emergence of intelligent life forms and civilization also requires many coincidences. Studies suggest that our solar system confirms the exceptional nature of life on Earth. This thesis can be questioned by arguing that life could evolve under different conditions and not be carbon-based. However, this argument is speculative, since the only known type of life is the carbon-based life present on Earth. The uncertainty comes from the lack of knowledge about the mechanisms of the origin of life, which makes it difficult to estimate its probability. The appearance of life is considered unlikely even by supporters of extraterrestrial civilizations, who propose the hypothesis of panspermia. Life could spread throughout the universe or be spread by advanced civilizations. This hypothesis does not solve the problem, it only transfers it to another world with similar improbability. One parameter of Drake's equation is the average life expectancy of technologically advanced civilizations, estimated by Drake at 10,000 years from when they can communicate with radio waves. The causes of its disappearance can be natural or cultural. If a civilization tends to annihilate itself, it is only a matter of time to invent the necessary means. Our civilization has had such means for decades but has survived until now. It is not clear whether characteristics such as hierarchical competition and authoritarianism are uniquely human or universal, linked to political evolution. Total destruction is not required for a civilization to stop communicating, it is enough to devolve to primitive levels. Natural catastrophes such as cosmic impacts or supervolcanoes also pose severe threats to a living planet and have caused mass extinctions in the past, such as that of the dinosaurs. These events would be difficult to prevent even for an advanced civilization. The problem is that there is no valid statistical data to estimate this average duration, since our existence is the only known case, which vitiates any extrapolation with an unwanted selection effect. Other solutions suggest that possible extraterrestrial civilizations are extremely far away from us and therefore physically cannot communicate with us, or simply do not want to because they might see us as a threat. Another solution suggests that an extraterrestrial civilization capable of communicating throughout the universe would be so advanced and self-sufficient that it would have no interest in establishing contact with our civilization. Finally, in favor of these theories, many argue that we also, despite being able to communicate by sending messages into space, do not do so actively. And if we received an answer, we would not be technologically advanced enough to be able to undertake interstellar travel. This contradiction between what we might expect to find given the vastness of the cosmos and our current experience has led to various theories and hypotheses to try to explain cosmic silence. From possible technological barriers to concepts like the Great Filter, different ideas have been proposed to address this mystery. The Great Filter hypothesis is a fascinating and deeply intriguing concept. This theory suggests the existence of significant and possibly insurmountable barriers that hinder, or even prevent, the development and prolonged survival of advanced civilizations capable of communicating across immense interstellar distances. The Great Filter was defined in 1998 by the American economist Robin Hanson as a type of barrier that inhibits the development of extraterrestrial civilizations lastingly over time. Hanson hypothesizes that our failure to find extraterrestrial civilizations in the observable universe implies the possibility of error within the various scientific theories according to which the development of advanced intelligent life is likely. This observation is conceptualized in terms of a great filter, which reduces the large number of places where intelligent life could form to the small number of advanced civilizations currently observed, which is only one, the human one. This mechanism, which could be in our past or in our future, could function as a barrier to the evolution of intelligent life, or as a high probability of its self-destruction. The main conclusion of this theory is that the easier it was for life to evolve to our current stage, the lower our chances of surviving in the future. The large filter is one of the possible solutions to the Fermi paradox. In addition to mass extinctions caused by devastating natural events, there is the disturbing possibility that civilizations may end up self-destructing through inherent misuse or abuse of their own advanced technologies. This could occur through nuclearized global conflicts, uncontrolled biotechnological experiments, or irreversible environmental collapses, reflecting a species incapable of wisely managing its technological advances. The idea of the Great Filter invites us to reflect on our own future as a species and the possible threats we could face. From a scientific perspective, the discovery of extraterrestrial life would have a profound impact on our understanding of biology and astrophysics. We would face new questions about how life arose on other planets and what forms it might take. On the other hand, from a philosophical point of view, the encounter with other civilizations would raise questions about our own humanity and our fundamental values. How would we relate to beings from other worlds? What would it mean for our beliefs and ethical systems? Ultimately, reflecting on the philosophical and scientific implications of the possible encounter with other civilizations in the universe invites us to broaden our mental horizons and consider the infinite possibilities that the cosmos has to offer. If you want to know other stories like this, discover the many characters in history, the many scientific discoveries of humanity and much more, subscribe to the channel and follow us.